University of Sri Jayawardenepura. Faculty of Technology. Department of Civil and Environmental Technology. X-ray diffractometry demonstration. X-ray powder diffraction is a rapid analytical technique primarily used for phase identification of a crystalline material and can provide information on unit cell dimensions. XRD is a non-destructive technique used to identify crystalline phases and orientation. Determine structural properties, such as lattice parameters, strain, grain size, epitaxy, phase composition, preferred orientation. Measure the thickness of thin films and multilayers and determine atomic arrangement. To unlock the doors, the user presses the open door button, the alarm light will blink while the doors remain unlocked. To open the doors, the user gently slides the doors apart by the metal fixtures. X-rays are generated by accelerating electrons into a copper target. X-rays are directed towards the sample where they diffract. Angles of constructive interference will diffract X-rays into the one-dimensional detector, which transduces the X-ray intensity. Sample collection and preparation. Obtain a few tenths of a gram, or more, of the material, as pure as possible. Grind the sample to a fine powder, typically in a fluid, to minimize the inducing extra strain that can offset peak positions, and to randomize orientation. Powder less than 10 micrometers in size is preferred. Place into a sample holder or onto the sample surface. Smear uniformly onto a glass slide, assuring a flat upper surface. Pack into a sample container. Sprinkle on double sticky tape. Typically the substrate is amorphous to avoid interference. Care must be taken to create a flat upper surface and to achieve a random distribution of lattice orientations unless creating an oriented smear. After loading a sample, the sample holder is placed onto the base of the sample stage fixture. Now it's time for the user to set up the scan using the instrument software. A scan method can be created or modified using the XRD wizard application from the desktop. From the application screen, a new method or previous method can be opened. The user can set the 2θ scan range, step size or number of steps per scan and time per step. The X-ray generator power for the scan can be adjusted up to 40 kV and 40 mA. Finally, the scan method is saved. Operation of the instrument is done through the XRD commander application, before starting a scan. The X-ray generator power must be slowly ramped up to its desired output. First voltage is increased at 5 kV increments by typing in the next value and clicking the set button. The X-ray generator is allowed to rest for 10 seconds before the user increases to the next set point. This slow ramp and power will ensure increased longevity of the X-ray generator. Next, the current is increased at 5 mA intervals in the same manner. After the target power has been achieved, the user can set up the next scan by clicking on the Jobs drop-down menu and selecting Jobs. This will open a new window where the user can add a sample ID, select a parameter file and save location for their sample. The user starts the selected scan by pressing the Start button. This will open the shutter of the X-ray generator and begin the scan. The intensity of diffracted X-rays is continuously recorded as the sample and detector rotate through their respective angles. A peak in intensity occurs when the mineral contains lattice planes with d-spacings appropriate to diffract X-rays at that value of θ. Although each peak consists of two separate reflections, K-alpha-1 and K-alpha-2, at small values of 2θ the peak locations overlap with K-alpha-2 appearing as a hump on the side of K-alpha-1. Greater separation occurs at higher values of θ. Typically these combined peaks are treated as one. The 2 lambda position of the diffraction peak is typically measured as the center of the peak at 80% peak height.